Parkinson's disease is a part of a family of neurological disorders that result from the loss of dopamine-producing brain cells. Everybody is probably familiar with this disease. If you have never known someone afflicted by it, you have almost certainly seen someone with it. Prominent symptoms include trembling, frequently in the hands, arms, legs, and/or jaw, stiffness in the trunk of the body, bradykinesia, which is a term used for slowness of motion, and posture instability, which correlates to poor balance. It generally affects people over 50 years of age, and the progression of the disease after onset can vary from patient to patient. Currently, there is no cure, and the most common treatment is medication that attempts to kickstart the production of dopamine in the brain. Why is this significant? It certainly isn't new news, but on April 23, 2014, a new innovative possible treatment was developed and the research was published in Science Translational Medicine. The story starts with cochlear implants, a technology which fairly obviously aims to improve the auditory capabilities of people with poor hearing. This technology has been in the works for more than 5 years.
The cochlear implant is an amazing device, but it's trying to do the job of a normal hearing ear, which is driving thousands and thousands of nerve fibers. We're using the bionic ear, the cochlear implant, in a very novel way to improve the range of sounds that the hearing disabled people will be able to appreciate. So it's really a hardware issue. The speech processor drives a limited number of electrodes, very small electrodes that are inserted into the cochlea, typically about 22 of those. The problem is the limited number of electrodes that are trying to selectively stimulate the tens of thousands of auditory nerve cells.
In hearing impaired people,
How we can connect the dots between Parkinson's disease and cochlear implants. Bionic ears, as they are being referred to in an article found in Neuroscience News, are being used to apply the same philosophy as cochlear implants, which stimulate the auditory nerve cells using electrode impulses. Similarly, bionic ears are using localized electrodes in deep brain stimulation to create a similar effect of regrowth on different specialized cells, such as ones used to create dopamine. This would be applicable in the treatment of Parkinson's disease, and possibly even some psychiatric conditions such as depression.
so what we do is use the cochlear implant itself to deliver the DNA to the nerve cells. This regenerates the auditory nerve fibers and greatly enhances the connection to the electrode.
So by creating a localized therapeutic gene delivery, we're able to draw the neurons back out towards the electrodes, closing the neural gap, and therefore we're able to more selectively stimulate those nerve fibers.